So here we go, evaluating expressions. We're going to use substitution because you'll notice here's the expression I'm to evaluate, m plus paren 3 minus q and paren squared. And they're telling us m is 12 and q is negative 1. So we're just going to substitute in. Where I see the m, I'm going to put the 12 plus my parenthesis then 3 minus the value of q. Now be careful here. Q is a negative 1. So you're going to show this, and I'll switch colors so you can see it, negative 1 like that. Okay, and then the squared. And now we simply apply order of operations. Again, I'll just do one step at a time. So 12 plus parenthesis 3 minus a negative. This double negative here becomes a plus. The opposite of an opposite is a positive. Two negatives make a positive. Think of it that way. I still work inside the parentheses now. So I've got 12 plus 3 plus 1, 4 squared. Now remember PEMDAS, so I've got to take care of, I've done what's inside the inside the parentheses. Now I have to take care of the e, the exponent. Okay, so right here I got to square this 4. 4 times 4 is 16. And then I do my final addition, which is 28. Again, we get that nice triangular pattern as we reduce our expression down to its final and simplest result. Here's another example. We got a plus b squared, and there's no symbol between the b squared and this paren, so that's going to imply multiplication right there. And b, take away a or subtract a and paren. Tell us what a and b are, so let's go ahead and do the substitution. So where there's an a, we put a 5. Okay, notice now it's got addition. This b squared right here, since an exponent implies multiplication, what you want to do is make sure you substitute by putting parentheses around whatever b is, in this case negative 3.2, and your squared, in parentheses. This is just a subtraction problem in here, so we don't have to put parentheses inside that parentheses. So it'd be b, which is negative 3.2, minus a, which is 5. So you can see all our parts match up. A is 5, our pluses are plus, b is this negative 3.2, and we got to square the entire b. And that's why we use those parentheses, to make sure we square that negative. Then our parenthesis matches up. B is negative 3.2, our minus sign, and a is just a 5. So everything lines up. Now we're going to just start to simplify this. These parentheses right here don't mean to do that first. These are just here to hold all that negative 3.2 inside this squaring function. What we want to do is this set of parentheses first. It turns out actually as you get better at math and more experience, it wouldn't matter if we did both at the same time. But for demonstrations, I'm going to do one step in each line. So negative 3.2 minus 5 is negative 8.2. Now I've done everything inside the parentheses I can do. I can't do anything inside there. I can't do anything inside here. I'm ready to deal with this exponent. Okay, so I'm going to have to square 3.2. And that certainly, you can just run off to the side and do it by hand. You can get out your calculator and square it. Make sure you put it in parentheses just like you see it though. But the result has got to be positive. And the reason it does is because a negative times a negative will always be a positive number. And so when you square 3.2, you get 10.24. And then we just continue on. Our next step is we've got two operations in here. We have addition, and this is a multiplication right here. So multiplication comes first. So we're going to have 5 plus, and we're going to take our 10.24 and take it times that negative 8.2. That's going to give us negative 83.968. And lastly, I would probably think of this more like 5 plus a negative just means subtract 83.968. And so we will do that math, and we'll end up with negative 78.968. And that's it. Now notice you do have to use a calculator for some of these problems, otherwise they take quite a bit of time. So it's just easier to have your calculator ready. Preferably not your phone calculator. Again, you can't use those on tests, so you need to practice with a real calculator. Again, we get that nice simplifying triangular shape that brings us down to our final answer. This is the last example. We got this big fraction here. Okay, now remember this numerator is one group, denominator another group. So we simplify the top, we'll simplify the denominator, and then we'll just simplify that fraction. So let's go to work. We got x to the fourth, so we're going to substitute in 4. X. We're going to substitute in negative 3. That's what our x value is. Again, parentheses, 4. Minus 3, we got multiplication here, so we're going to put parentheses as we substitute in. All over. Next comes our y value to the third power, so that's negative 5 to the third, plus 2 times w, and since it's multiplication, we're going to use parentheses like that. And then we'll just work in the purple and the red, the numerator and the denominator separately. So I'll draw our fraction bar right here. Let's take negative 3 to the fourth power. Now when you do that, you have to make sure you put that in parentheses. But it's going to be a positive number, so we're going to get 3 times 3 is 9, times 3 is 27, times 3 is 81. So we got 81 minus 3 times 4 times negative 5. In our denominator, we have to take care of that exponent right here first. So we have to go 5 times 5 is 25, times 5 is 125. And again, because it's negative, this is an odd number of negatives multiplied together. The first pair of negatives become positive, but then you take it times that third negative, and it becomes negative again. So that's going to be a negative 125. Plus 2, and then our parentheses times 4. So that's a one step in the numerator and one step in the denominator. Let's go back to the numerator now. We've got our 81 minus, and we just have to multiply these three numbers together. Okay, 3 times 4 is 12, and 12 times 5 is what? 60. Now, you'll notice we got minus. There's two ways to do this. One way is to think of it as just a positive 3 times 4 times 5 times negative 5 rather. Okay, in which case you'd get a negative 60. Or you could think of it as a negative 3 times 4 times negative 5. Those double negatives become a positive. Either way, when we do it the first way, you're going to see we get this minus minus, which will become a positive in our next step. The denominator, we've got one multiplication we have to deal with, like so. And I'm going to show all the steps here. This would be 81. Those become positive, the opposite of an opposite. And negative 125 plus 8 is going to give us negative 117. Oops, let's get to red. And finally, we'll just add our numerator terms together. The 81 plus 60, 141. And our denominator is negative 117. Now, you should check to see if you can simplify that fraction. Okay, there's a couple ways to do it. I believe, let's see here. Let's see if we can figure out. There's a way to do this on your calculator, but I'm not going to show that yet. But I do notice if I add up the digits in 141, 1 plus 4 is 5, plus 1 is 6. 6 is divisible by 3. 1 plus 1 is 2, plus 7 is 9, and 9 is divisible by 3. And if the sum of the digits are divisible by 3, the number itself is divisible by 3. So if I take 141 and reduce it by dividing it by 3, it simplifies to a 47. And if I take 117 divided by 3, it comes out to a 39. Now I still haven't marked my minus sign or my negative sign right here. That negative you could put in the denominator. You could put right even with the fraction bar, or you could put it with the numerator. And in general, I think it's best to put it with the numerator. So negative 147 over 39 would be our final answer. If I type that into my calculator and get a decimal, it's really messy. Trying to look, it looks like you'd have to rewrite it as negative 1.205128. And while this is perfectly fine, this is clearly much easier. I could stop right at that point with the fraction, wouldn't have to get out my calculator and do that at all. So we'd prefer that answer as a fraction, but also know how to convert it to a decimal.